For over a century, the story seemed settled. Textbooks taught it with quiet confidence. Homo sapiens emerged in Africa, spread across continents, and replaced their less advanced cousins, the Neanderthals, who faded into extinction around 40,000 years ago. It was a narrative of conquest, of progress, of one species outsmarting another. In museums, Neanderthals were cast in plaster, heavy-browed, hunched, wordless. In films, they grunted, dragged clubs, and vanished. In classrooms, they were defined by what they lacked: art, speech, culture, complexity. And in the public imagination, they were little more than failed prototypes. We were the finished product. But what if that story, clean, simple, triumphant, is not only incomplete, but fundamentally wrong? What if the extinction of the Neanderthal wasn't an ending, but a transformation? Recent decades have cracked the surface of that comfortable tale. Fossils once misinterpreted are being re-examined. Genetic tools are revealing ancestral whispers hidden in our blood. And a quiet, profound possibility is emerging: that Neanderthals didn't disappear. They became part of us. In particular, one unsettling thread is being tugged: that some modern human populations, especially in Northern Europe, may not be merely related to Neanderthals, but directly descended from hybrid ancestors. Not a replacement, but a fusion. It's not a claim shouted from podiums, yet. But in the quiet corners of paleoanthropology and ancient genomics, the evidence is mounting. It challenges the way we think about identity, ancestry, and even the traits we call European. So if the old map no longer leads us to truth, perhaps it's time to turn it upside down. Because a few names, a handful of bones, and strands of DNA are beginning to tell a different story. One we were never taught to read. Long before we decoded DNA, our first glimpse into human ancestry came from stone and bone. Yet for decades, some of the most significant Neanderthal fossils were misread through the lens of bias, not science. And some of the loudest whispers about our origins were tragically ignored. Take the case of La Chapelle-aux-Saints I, unearthed in France in 1908. Early reconstructions portrayed him as hunched and brutish, the quintessential caveman. But this image was deeply flawed. The posture that suggested primitiveness was, in fact, the result of advanced arthritis. Corrected for his condition, the skeleton stood tall and balanced. His brain, astonishingly, measured over 1,600 cubic centimeters, significantly larger than the modern human average. The narrative began to crack. Nearby, in the same region of southwestern France, archaeologists uncovered Le Phérécier I, another Neanderthal male, buried deliberately in a grave outlined with stones. His body had been laid with intention, limbs arranged, head turned, possibly even covered. This wasn't random death. This was ritual. And like La Chapelle, his anatomy defied caricature. His skull was broad but high, his face forward set yet refined, and his teeth showed signs of controlled wear, possibly even speech adaptation. Something didn't add up with the old assumptions. Then there is Lakina 5, less discussed but no less remarkable. A Neanderthal adolescent whose remains suggested a more graceful build, with reduced brow ridges and a shorter face. Found in Charente, France, she may represent yet another case where Neanderthal features overlapped with early Homo sapiens, not just in form, but perhaps in lineage. What connects all these individuals isn't just geography or time. It's ambiguity. These skeletons inhabit a strange in-between, not fully Neanderthal in the old sense, yet not quite modern either. Their features blur, their behavior suggests symbolism, and their timing aligns with a key moment in human prehistory, the arrival of Homo sapiens in Europe. Could they be evidence of early hybridization, not fossils of extinction, but of convergence? The silence of stone is deceptive. These bones are not echoes of something lost, but artifacts of something becoming. the early blending of two human lineages into one. Still, bones can only hint at truths. They capture form, posture, injury, and intention. But to understand inheritance, we must go deeper, beyond the grave, into the code we carry. Because bones whisper, but DNA remembers. Fossils speak in silence, but DNA murmurs in every cell. And lately, it's begun to say things we weren't prepared to hear. When the human genome was first mapped, something unexpected surfaced. Small fragments of Neanderthal DNA, woven into the double helix of modern humans. At first, it was thought to be a trace, a remnant, perhaps the product of a few fleeting encounters, a statistical curiosity. But what mattered wasn't how much we carried, it was which parts. Among Europeans, especially those in northern populations like Finns, Estonians, and Latvians, a series of gene variants stands out. These aren't just inherited quirks. They're functional signatures that shape our very appearance. Take SLC24A5, a gene that regulates melanin production. One of its Neanderthal-derived alleles lightens skin, allowing better synthesis of vitamin D in low UV environments. It's nearly universal in northern Europeans. Then there's HERK2 and OCA2, which govern eye pigmentation, specifically blue and green hues, rare in most of the world but strikingly common in Scandinavia and the Baltic. And MC1R, the gene behind red and blonde hair, carries variants known to originate in Neanderthal lineages. This isn't random inheritance. It's introgression, the genetic legacy of hybridization between Neanderthals and Homo sapiens, followed by natural selection that preserved certain traits because they helped people survive in Ice Age Europe. Light skin absorbs more sunlight. Pale eyes may have had optical advantages in dim northern light. Even traits like pain sensitivity, vigilance, and immune response show signs of Neanderthal influence, tuned, perhaps, to the cold and the pathogens of the prehistoric North. And while the average European may carry only 1.5–2.5% Neanderthal DNA overall, these percentages hide the real story. Because these aren't passive fragments. These are adaptive genes, finely tuned by environment and preserved by survival. If you could peel back your genome and read it like a book, you wouldn't find a single page marked Neanderthal. You'd find whole passages, still in use, still performing, still helping you adapt to the same world they once called home. Which raises a deeper question. What if we haven't just inherited a sliver of Neanderthal? What if we've inherited their most defining strengths? And if these traits, so visible, so dominant in Northern Europe, descend from Neanderthal stock, then that 2% isn't just a genetic footnote. It may be the root. Picture Northern Europe not as we know it today, but as it stood during the last glacial maximum. Vast walls of ice pressed down from the north, glaciers stretching over what would become Scandinavia, Finland, and the Baltics. The land was not only frigid, it was cut off, surrounded by seas, mountains, and unrelenting snow. What life remained had to endure in pockets, islands of survival in a continent frozen in time. It was in this crucible of cold that a unique population persisted. Descendants of both Homo sapiens and Neanderthals. These hybrid humans weren't just surviving, they were adapting, refining traits that had allowed their Neanderthal ancestors to endure this land for over 300,000 years. Thick bodies conserved heat. Lighter skin synthesized precious vitamin D from pale sunlight. And certain neurological traits, heightened vigilance, resistance to cold-induced pain, helped them stay alive in an environment that left no room for error. But beyond the body, something else was happening. The cold was shaping the gene pool itself. Geographic isolation sealed the north, while waves of Homo sapiens moved into southern Europe and the Middle East, bringing agriculture, culture, and new genes. The far north remained static. A genetic bottleneck formed, populations shrank, and those who survived passed on a narrow but concentrated set of genes. Ancient alleles, including those inherited from Neanderthal ancestors, became more frequent, not less. Today, genetic studies show that Finns, Estonians, and Latvians stand apart from other European populations. Their mitochondrial haplogroups, such as U5 and V, are among the oldest in Europe, closely linked to Ice Age hunter-gatherers. Their genomes contain Neanderthal-derived traits at higher frequencies than almost anywhere else on Earth, not because they are more Neanderthal, but because they were less changed. By contrast, Southern Europeans, Greeks, Italians, Iberians bear more admixture from Neolithic and Bronze Age migrations. As civilization flourished in the Mediterranean, it also diluted the ancient hybrid traits. What remained in the north became something rare, a preserved echo of a deeper ancestry. In Finland, in the Baltics, in the icy forests of Scandinavia, the cold did not forget. It became a conservator of ancient bloodlines, traits selected not for culture or beauty, but for survival. And that survival begs the question: if Northern Europeans carry a concentrated legacy of Neanderthal ancestry, then perhaps we've misunderstood what it means to be modern. Because if the oldest parts of us survived the Ice Age, then maybe the real story isn't about who replaced whom, but about who endured. We've long believed we know how the story ends. Neanderthals, those robust, cold-adapted humans, vanished from the Earth some 40,000 years ago, leaving Homo sapiens alone to shape the future. It's a neat conclusion, one that fits into a tidy evolutionary ladder, from primitive to advanced, from obsolete to dominant. But nature rarely follows neat conclusions. And the fossil record? It has a way of reminding us that history is far messier than our diagrams allow. In recent years, AncientDNA has begun to rewrite this narrative, not with sweeping declarations, but with quiet contradictions. Researchers have uncovered Neanderthal individuals with surprising features: genes for pale skin, light hair, and blue or green eyes. These aren't theoretical extrapolations. They're real, tested markers, extracted from bones that predate the supposed Neanderthal extinction. One variant of the MC1R gene, for example, linked to red hair and freckling, is found in modern European populations, but also in Neanderthal remains from over 50,000 years ago. The HERK2 and OCA2 genes, associated with eye color, especially blue and green shades, likewise trace back to ancient, pre-sapiens lineages. And remarkably, they appear in regions where Homo sapiens had not yet fully arrived. This means that traits once thought to define modern Europeans existed before modern Europeans ever did. And this opens a provocative possibility: that we didn't invent these features, we inherited them, not from some abstract, distant common ancestor, but from a group of people we once thought were gone. People who may have met us, mingled with us, and through interbreeding, left behind a legacy more intimate than we've ever acknowledged. Especially in Northern Europe, where isolation and climate pressure preserve those archaic genes, the resemblance is striking. Light eyes, broad cheekbones, stocky frames, low melanin pigmentation traits that may owe less to Homo sapiens innovation and more to Neanderthal adaptation. If so, then the question we've been asking, did Neanderthals go extinct, misses the point entirely. Because if their DNA still shapes our appearance, our immunity, our very physiology, if their traits echo through generations of Finns, Estonians, Lithuanians, and beyond, then Neanderthals didn't vanish. They became us. So perhaps the question isn't whether Neanderthals survived the Ice Age, but how much of the Ice Age still survives in us. History likes clean endings. It prefers clear timelines, simple transitions, and species that come and go in tidy succession. But real history, human history, is rarely so polite. If you live in Northern Europe, if your roots lie in Finland, Estonia, Latvia, Lithuania, or the icy coasts of Scandinavia, you may carry more than just the legacy of modern humans. You may carry a story older than your family tree, older than cities, agriculture, or even the words you use to describe yourself. You may be, in part, Neanderthal, not a relic, not a mutation, but a living echo of a people long thought extinct. The Neanderthal legacy isn't measured in bones alone, or even in the 2% of DNA that textbooks casually mention. It's written in the shape of your skull, the way your immune system reacts to the world, the color of your eyes, and the way your body metabolizes food in the cold. It's there in your skin, adapted for dim, northern light. In your pain receptors tuned, perhaps for life in a harsher world. In your face, broad, pale, quietly ancient. Because while southern populations absorbed migrations, intermixing with waves of Homo sapiens from warmer climates, the far north remained isolated geographically, genetically, and climatically. It became a genetic time capsule, preserving traits that elsewhere faded. Here, in this frozen crucible, the hybrid survived. The lines between Homo sapiens and Neanderthal didn't blur, they merged. And the product wasn't a failure or a fluke. It was you. So what does it mean to gaze into the mirror and know that your features, those you've known all your life, might be the culmination of an evolutionary union once thought improbable or impossible? It means the Neanderthals never truly left. They walked into the future wearing new faces. It means that human identity is not a monument, it's a mosaic. It means survival didn't come through purity, but through mixture, through sharing. In your pain receptors, tuned perhaps for life, in a harsher world. In your face, broad, pale, quietly ancient. Because, while southern populations absorbed migrations, intermixing with waves of Homo sapiens from warmer climates, the far north remained isolated geographically, genetically, and climatically. It became a genetic time capsule, preserving traits that elsewhere faded. Here, in this frozen crucible, the hybrid survived. The lines between Homo sapiens and Neanderthal didn't blur, they merged. And the product wasn't a failure or a fluke. It was you. So what does it mean to gaze into the mirror and know that your features, those you've known all your life, might be the culmination of an evolutionary union once thought improbable or impossible? It means the Neanderthals never truly left. They walked into the future wearing new faces. It means that human identity is not a monument, it's a mosaic. It means survival didn't come through purity, but through mixture, through sharing.